All right, so first topic we will take a look at is going to kind of combine using synthetic division, the rational root theorem, and finding real and complex roots of a polynomial. So it's going to be all three of those topics in this one question. Okay. So they want us to find all the roots of x cubed plus 4x minus 5. Okay, since it's a cubic, can you throw it into quadratic formula? Mm-hmm. No, you got to get it from a cubic down to a quadratic first, but to do that, we got to find a root. So how can I figure out a list of numbers to start thinking about trying? Yep.
Take the coefficients of the constant and coefficients of the leading coefficient.
Yep. So we're going to write down the p and q values. And what are the factors of p, which is the constant?
1.
Yeah.
Oh, sorry.
Yeah.
Plus 1 minus 1 and plus 1 minus 5.
Okay, so plus or minus 1 and 5, that's all you got. And then what are the factors of the leading coefficient?
Plus or minus 1.
Just plus or minus 1. So now we're going to put them together to make a list of possible rational roots. Okay. Jose, putting that all together, what would be my list of possible rational roots?
Plus or minus 1 and 5.
Yeah, if you take all the p's and divide by all the q's, well, q is just a 1, so that doesn't do anything really. So it's just plus or minus 1 and 5. Now, we could try these if we wanted in our head, or to narrow the list down. If, let's say there was like a lot of them, what would we want to do now?
Graph.
Yeah, we want to graph it and narrow this list down. X cubed plus 4x minus 5, I can kind of tell which one it already is by plugging it in. It's going to be 1, because 1 cubed is 1, 4 times 1 is 4, 1 plus 4 is 5, and 5 minus 5 is 0. But let's say we didn't know that it was going to be 1. We would graph it, and then we're going to look at the x-axis, and we're going to see where it crosses. 1, -1, 5, or -5. It definitely crosses at 1. Okay, so no question on that. So now, what are we going to do with the 1 to turn this cubic into a quadratic?
Use synthetic division.
Yep, we're going to divide through synthetically by the number 1. And what would my coefficients be?
1, 4, -5. Oh, no. 1, 0, 4, -5.
1, 0, 4, -5. Okay, so bring down the 1. What's 1 times 1? 1. And 0 plus 1? 1. And 1 times 1? 1. 4 plus 1? 5. And now I'm just doing this to make sure I did get a remainder of 0, but I really have the part that I need. 1 times 5?
5.
5. And then when you add that column up?
0.
0. So we just proved using synthetic division that 1 is a root. Okay. So we'll start our list of roots. We have the 1. And let's identify that. Is that rational, irrational? Is it real, or is it imaginary?
Rational.
It's rational. And then is it real or imaginary?
Real.
It's real. So this is rational and real. That's how you would classify it. All right. Now we're going to find the other roots. Okay. So to find the other roots, what part of the synthetic division am I interested in using now?
First 3.
Yeah. And what's this part called? Yeah, this part is your quotient. This is A, that's B, and that's C. Because now we're going to get ready to solve that using the, we got to use the quadratic formula. So Leah, can you tell me when I do quadratic formula using those, how do I set it up?
-b.
Yeah, and what would be the number?
-1.
Mm-hmm.
Plus or minus the square root of, is it b? Or so
B,
negative? B squared.
B squared.
So 1.
Yep, so 1.
minus 4ac.
So 4ac, and that's going to be divided by
2a.
2a, which is
1. 2.
2. Okay, so now we've got that. Now once we simplify it, those are going to be our roots. -1, plus or minus. Sophia, what's 4 times 1 times 5?
20.
And 1 minus 20?
-19.
-19. So you know what? Let's do it like this. What's the square root of -19?
Is it like you take out the negative, you get I square root of 19?
I square root of 19. Yep. Over 2. Now the only thing, whether they asked to do this part or not, would be to write it in standard form. So what would be your real part in standard form?
-1/2.
So -1/2 plus or minus, and what would be your imaginary part?
I square 19.
Yeah, we usually put the I right there. Okay, so these are our roots. Now, what about these? Are those real or imaginary? Those are imaginary. So if you have to classify them, the first one was rational and it was real, and the second one is imaginary. So that covers synthetic division, finding roots, and there was one other thing it covered: synthetic division, rational root theorem. Yep, we did all of them there. Any questions on that one?
Which was the rational root theorem?
The rational root theorem, that's when we did the P and the Q part.
Oh, okay.
So that was the rational root theorem, this was the synthetic division, and then the last part was quadratic formula to find the roots. Alright, so this one is going to cover how to do long division. It's the same division that we did in the last problem with synthetic. So if we get x squared plus x plus 5 with a remainder of 0, we know we did it right. Okay, so let's see. All right, long division. What goes on the outside when I do the long division?
X minus 1.
X minus 1. And what's going to go on the inside?
No problem.
All
Can you tell me exactly what to write?
x cubed plus 4x. Oh, plus 0x squared.
Plus 0x squared, yeah.
Plus 4x minus 5.
Plus 4x minus 5. Okay, so we got to make sure we fill in zeros for anything we're missing. Now, take the first term of what's on the outside and divide it into the first term on the inside. What's x cubed divided by x?
X squared.
X squared. Now, what do we do with that x squared?
You multiply it by the x and the negative one.
Yep, I'm going to multiply it back out. X squared times x is going to give me
X cubed.
x cubed, and x squared times -1,
Negative 1.
negative x squared. And what do we do with these columns? Subtract them. Okay, x cubed minus x cubed?
0.
0. 0x squared minus x squared.
X squared.
X squared. And then our next step is to
Drop down the 4.
Yep, bring down the 4x. And we keep going until this exponent is smaller than that one, or we get a remainder of 0. So now, what's x squared divided by x? X. Multiply the x back out. X times x.
X squared.
X times -1.
Negative.
X. And now take your columns and
Subtract.
subtract. Synthetic is so much faster. So x squared minus x squared cancels out. What's 4x minus x?
5x.
So 5x. And then bring down your 5. Okay, so we got to go one more time, and this will be the last time. What's 5x divided by x? 5. Now multiply the 5 back out. 5 times x? 5x. We kind of already know what's going to happen here. What's 5 times negative 1? Negative 5. Subtract. What's 5x minus 5x?
0.
Gone. And what's negative 5 minus negative 5?
0.
That's gone. So we get a remainder of 0. So the quotient is x squared plus x plus 5. 1, 1, 5. And if we look back at the other problem we did, 1, 1, 5. Exactly the same thing. Now remember, you can only use synthetic division when you're dividing by x minus a number. If you're dividing by something more complicated, you have to use long division. Okay, so in this one, they want us to find the remainder. They are not interested in the quotient. And the quotient would be kind of a pain to find, because you've got this x to the 12th, so then you'd have to fill in every term you're missing as a 0. X to the 11th, 10, 9, 8, 7, 6, 4, 3, 2. You have a lot of zeros you have to fill in, and that would take, even with synthetic division, that would still take a little bit of time to do. So the remainder theorem says you can take the number after the minus sign. So in this case, it's a 5. And what are we going to do with the 5?
Plug it in for x.
Plug it in for x where?
And the quotient.
In the
Top.
Yeah, in the top. So we're going to take the 5 and we're going to fill it into the top. That's a lot faster than having to do the long division. I am going to need a calculator unless somebody already has this answer.
I'm doing it right now.
So it's 5 to the 12th minus 4 times 5 to the 5th plus 15 minus 2. Did it come out in scientific notation?
It's a really long number, but not scientific.
Oh, it's not scientific. All right, just tell me the numbers.
2, 4, 4, 1, 2, 8, 1, 3, 8.
Okay. So 244,128,138.
Mm-hmm.
Now, look, did I get that right?
What's the remainder?
So that would be the remainder if you tried to do that out. So definitely not feasible to do with long division or even synthetic. I mean, look how big that number is. You're going to mess something up.
Oh yeah, no, because you have to have all the zeros.
Yeah, because you got to put in all the zeros from the 12th power all the way down to the ones you're missing. So that's the remainder theorem. Any question on that?
No.
Okay, so in this one, we're going to determine if 3 is a root of that polynomial. And I want to do it using synthetic division. So how do we determine if 3 is a root using synthetic division? What goes on outside? Just 3. You put the root itself on the outside. If you were writing it as a factor, then you would put x minus 3. That would be the factor. And I don't even know if it really is the factor. That's what we're checking. Okay, and what would be the numbers here?
2, 2, 8, 3, 1.
3 and 1. So no zeros to fill in that time. Okay, so bring down the 2. 3 times 2? 6. What's negative 8 plus 6? Negative 2. 3 times negative 2? Yeah, negative 6. What's 3 minus 6?
Negative 3.
So negative 3. And then 3 times negative 3? Negative 9. And 1 plus negative 9? Negative 8. So is 3 a root of that polynomial?
No.
No. How come?
It has a remainder.
Yeah, it has a remainder of
Negative 8.
negative 8. That's the remainder. Didn't go in evenly. So it's not a root. Now, if they said determine if x minus 3 is a factor, you do exactly the same thing. You just have to know that the number you put on the outside is what comes after the minus sign. So any question on if they wrote the problem, determine if x minus 3 is a factor, how to do it? It's pretty much the same thing. Okay. Okay, so in this one, we're going to take a look at how we can construct a polynomial that has given roots. Now, they've told you here that they want you to have roots of 2 and 3 plus 4i. Is there anything else you know that would have to also be true here, even though they didn't say it? Yeah?
3 minus 4i is also a root.
Right, 3 minus 4i would also have to be a root. Now, once we know the roots, what's the first step towards figuring out the polynomial? We take all the roots and turn them into factors. So now we're going to figure out all the factors that would make up the polynomial we're trying to find. If 2 is a root, what would be the factor that would have given you 2 as a root?
X minus 2.
Right. It would have been x minus your root. Now, if 3 plus 4i is a root, what would have been the factor that came from?
X minus 3 plus 4i.
X minus the root. And if 3 minus 4i is one of the roots?
X plus
X minus 3 minus 4i.
X minus 3 minus 4i. It's always x minus the root. Now, when we write a polynomial, can polynomials have imaginary numbers and constants? No. So all the imaginaries here should cancel out. So my suggestion is to always FOIL that first, and then do the x minus 2 last. Okay. What should we do inside each of those parentheses first?
Distribute the negative.
Yeah, let's distribute the negative. What do you get in the first one when you do that?
X minus 3 minus 4i.
And the second?
X minus 3 plus 4i.
All right. Now, we're going to FOIL, not really FOIL, but we're going to distribute everything in the first parenthesis to everything in the second. All right. What's the first thing you would multiply?
X times x.
All right. Let's do x times x, and that's going to give me x squared. What about x times negative 3?
Negative 3x.
Negative 3x, and x times 4i.
4ix.
Plus 4ix. Okay, next one. Negative 3 times x.
Negative 3.
Negative 3x. And negative 3 times negative 3.
Plus 9.
Plus 9. And negative 3 times 4i.
Negative 12.
Negative 12i. Okay, and the last one. Negative 4i times x. Negative 4ix. Negative 4i times negative 3.
Negative 12i. Oh, positive 12.
Positive 12i. And negative 4i times positive 4i.
Negative 16i squared.
So that's a negative 16i squared, which is
So
really what
16.
number? Positive 16. Okay, so now, if nothing canceled there, that would be a mess to have to FOIL with x minus 2, but a lot of it is going to disappear. What cancels out?
Plus 4ix and minus 4ix.
Plus 4ix minus 4ix, yep.
12i. Negative 12i.
So negative 12i and positive 12i. Okay, so now we're left with x minus 2. And what's going to be my other factor?
X squared minus 6x plus 25.
Plus 25. 6x plus 25. Okay, so now x squared minus 6x plus 25, that's a parabola that would have those as the answers. Now what we want to do is make it a cubic that also has that as the answer. So we just have to FOIL it with the x minus 2. All right, let's do that. Okay, x times x squared. X cubed. X times negative 6x.
Negative 6x.
And then x times 25.
25x.
X. And negative 2 times x squared.
Negative 2x squared.
then that one, negative 2 times negative 6x.
Positive 12x.
Positive 12x. And negative 2 times 25.
Negative 50.
Negative 50. So now we're ready to write our cubic polynomial. So it's going to be x cubed. What about the x squareds?
Minus 8x.
Minus
8x squared.
8x squared. Yep.
Plus 37x.
Plus 37x. Okay.
Minus 50.
Minus 50. So that is a polynomial that would have those three numbers as the roots. Okay. Any questions on it?